so now that we've learned how to graph exponential functions, we're going to be talking about finding some of the key features of exponential functions and how we write them. Okay, so here, starting with this exercise 1, we're going to state what the initial value is, what the base is, and whether it's growth or decay with justification. Okay, so generally our exponential function follows the pattern f of x or y. Okay, again, it doesn't have to be f of x, it could be g of x, h of x, anything of x. We normally just use f because f for function. Okay, so f of x, also known as y, equals a times b to the x power. Okay, a here is normally our initial value. Okay, and then b here is our base. Okay. And then if we ever move the exponential function up or down, then we have a c at the end. If it moved up and moves our asymptote up, then it's plus whatever it is. If it moved down, then it'll be minus. Okay? And then how we know if it's growth or decay, we know that it is exponential growth when our base is bigger than 1. Okay? And in that case, then our graph would look like this, and it would go up. Okay, it would be decay if our base is less than 1, and in that case, it would go down closer and closer to our asymptote, and it'll kind of flatten out-ish. It'll get closer and closer to our asymptote without touching it. Okay? So here we have a couple of examples. We're going to state the initial value, what the base is, and whether it's growth or decay with justification. Okay. So here, our initial value is 4, because that's where A is. Our base is 3/4, and it's going to be a decay, exponential decay, and the reason why is because 3/4 is less than 1, right? 3/4 we know as 0.75, and that is less than 1. Okay, so this would be an exponential decay. Okay. So here we have the next one, f of x equals 0.5 times 5/2 to the x power. Okay, our initial value, our a here, is 0.5. Our base here is 5/2. Our type of exponential, this is growth. Okay. And the reason why is because 5/2 is greater than 1. 5/2, if we changed it into a mixed number, we know is 2.5, and 2.5 is bigger than 1, right? A lot of the time, students want to just go on based on whether it's a fraction or not, but please remember, fractions can be less than 1, like we had in our first example, or fractions can be bigger than 1. Okay. So next we have C here. Our initial value, f of x equals 2 times 1.2 to the x power. Our initial value here is 2. Our base here is 1.2, because that's the number that has the exponent, and this would be exponential growth. Okay. And the reason why is because our base here, 1.2, is bigger than 1. Okay. And then last one here, can you try it on your own? Okay, so find initial value, base, exponential, and then come check your answer. Okay, this is what you should have gotten. Your initial value is 1/2. Your base is 0.80. This is a decay function, and the reason why is because 0.80 is less than 1. Right, so now whenever we have problems, we need to write equations. We'll see this tomorrow as we're doing word problems and writing the equations for them. We really just need to find the initial value and the base, what we're multiplying consistently by. Okay, and we can tell whether it's growth or decay by whether it is bigger than 1 or less than 1. Okay. So the last thing we're going to do here is identify whether it's an exponential function. Okay, so exponential functions have a constant ratio, something that they are consistently multiplied or divided by to go from one y value to the next y value. Okay. To find this ratio, all we have to do is take one of the y values and divide it by the previous y value. Okay. So that's what we're going to do here. We have three different types of relations. Okay? And what we're going to do is we're going to determine whether the information we're given, the set of data shown below, whether it displays exponential behavior. Okay? We're going to write yes or no. We're going to explain why or why not. And if it's exponential, we're going to write the equation. Okay? So here, we go 0, 5, 10, right? So what we notice here is 64 to 32. What happens if I take this and divide by the previous one? Right, so 32 divided by 64, this gives us 1/2. Right, so 64 to 32 here, we multiply by 1/2. Okay, let's see if this is true. 32 to 16, okay, again, we did 16 over the one that came before. Okay, we also get 1/2. Okay, and what we should notice is each time here, 16 to 8, we multiply by 1/2. 8 to 4, we multiply by 1/2. 4 to 2, we multiply by 1/2. Okay, because, again, exponential functions have a constant ratio, something that it's consistently multiplied by. Here, we consistently multiply by 1/2, so this is an exponential function. Right? And the reason is because it has a constant ratio of 1/2. Right? And so to write our equation, we're going to write y, or f of x, equals, we're going to start with our starting amount here. So here, looking at our y-intercept, it's 64. I'm going to use that as my starting amount. This here is A. And then I'm going to multiply my constant ratio. We just found that our constant ratio is 1/2. Right? Raised to the x power. Okay. And so that's it. Okay, so here we have our x values 0, 3, 6, 9, 12, 15. Here 12, 16, 20, 24, 28, 32. What you should notice is we're not multiplying by the same thing. Instead, we are adding the same thing. Each time here we're adding 4. Okay. This is not exponential. Okay. The reason why is because we are not multiplying the same thing. So it is not exponential because it does not have a constant ratio. Right? It doesn't have something we consistently multiply by. Right? If we were to see 16, this time here we moved and multiplied by 4/3. Okay, 20 over 16, this time we multiplied by 5/4, right? So we're not multiplying by the same thing, because the first time we multiplied by 4/3. Okay, this time here we're multiplying by 5/4, it's not consistent. Instead, because we're adding, this is actually a line. It's a linear function, which we learned last semester. Okay. So let's do one more here. So to find my consistent ratio, okay, I'm going to take the one I have divided by the previous one. So I'm running out of space. I'm going to do it to the side here. Okay, so 25 divided by 10. This simplifies to 5/2. So to go from here to here, I multiplied by 5/2. Okay, then let's see if it's consistent. Right, so the next one, I have 62.5 over 25. And if I simplify this, this is also 5/2. So to go from 25 to 62.5, I also multiplied by 5/2. Okay, and then to check it again, 156.25 divided by what happened earlier, 62.5. This also simplifies to 5/2. Okay, so here, each time to get to the next y value, I multiply by 5/2. So as a result, it is exponential because it has a constant ratio of 5/2. Right? And so if I were to write it, y, or f of x, okay, again, doesn't matter. equals, I'm going to find my starting amount. So here is where my y-intercept is. Okay, so 10 times 5 halves, which is my constant ratio, to the x power. And that's it for today. Have a great rest of the day. Bye, guys.